Hello, my name is Atsushi Marui. I will be presenting the results of subjective evaluation of stereo microphone configurations comparison on loudspeakers with optimal source distribution. So, what is optimal source distribution, OSD in short? It is an implementation of crosstalk cancellation for binaural sounds playback on a set of loudspeakers. OSD has wider dynamic range and more robust to-wall reflections compared to conventional crosstalk cancellation methods. It can be used for enjoying binaural contents as well as virtual auditory space rendering through binaural processing. Recording binaural contents is necessary for OSD playback, but recording binaural contents is problematic, especially in live space. If a dummy head microphone is placed on an audience seat, noise from nearby audience can get in the recording. If a dummy head microphone is hanged like a stereo microphone setting, it can be visually distracting. So, our interest in this presentation is on investigation of effects and impressions of conventional stereo recording and comparison of it to the binaural recordings, both played back on an OSD system. Because OSD is often implemented as soundbars, we are going to use one. Use of OSD in an anechoic chamber guarantees the original binaural sound played back at listeners' ears. But for the sake of ecological validity, the experiments were done in a quiet listening room with wall and floor reflections. Before diving in, let us review the reproduction types. This picture shows the different recording and playback types. On top left, sound captured with stereo microphones played back through stereo loudspeakers is shown. This is conventional stereo playback of stereo contents. On middle right, sound captured with a dummy head played back through a pair of headphones is shown. This is binaural playback. With crosstalk cancellation system, we can listen to binaural contents without headphones. What we would like to see is the comparison of stereo recording and binaural recording played back on crosstalk cancelled loudspeakers, as well as conventional stereo playback. Sound stimuli have to be prepared before the listening experiment. We recorded a Mozart string quartet in a recording studio at our university. Here is the microphones used in the recording. Neumann KU100 was placed 150 centimeters away from the instruments. Two pairs of AB stereo microphones, Sennheiser AD20, are placed just above the dummy head. Distance between left and right microphones were 50 centimeters and 16 centimeters. One pair of AB stereo microphones, DPA 4006, was placed at location usually done for capturing the instruments and ambience. This is the photograph taken from the side. Now, we have the recordings, but there is one thing we have to do for playback of stereo contents on OSD loudspeaker. Because OSD cancels the crosstalk between left and right channels, Simply playing the stereo recording on OSD loudspeaker will make sound image biphonic, not stereophonic. So we have to do something to create stereophonic sound image. So here is what we did. Binaural filter simulating loudspeaker playback was made from anechoic impulse response measurement of B&W 801 with the same dummy head used in stimulus recording. When this filter is applied to AB stereo recording, the listener can experience the sound of stereo loudspeaker placed in plus or minus 30 degrees through binaural rendering. These processes made 7 stimuli, 1 dummy head recording, 3 AB stereo recordings, and 3 AB stereo recordings with loudspeaker simulation filter. Now, let's listen to each of them. Subjective evaluation experiments included 3 tasks that are explained later. All participants were undergraduate or graduate students at sound recording program in Tokyo University of the Arts. They had at least 2 years of technical ear training and sound recording experiences. The playback system we used is a Sherwood S7 soundbar, which implements OSD. The listening room is compliant to ITUR BS 1116. Experimental GUI and sound are sent from PC through HDMI to the loudspeaker and a computer display monitor. Participants controlled the experiment application software running on the PC with wireless keyboard and mouse. The first task in the experiment was attribute elicitation. We used a method inspired by repertory grid technique. Listener is presented with 3 different stimuli. The listener can switch between the stimuli at any time, like exclusive solo button. They were asked to choose the most different one and describe how or why it is different from the other two. This was done for all combinations of stimuli. We collected 458 words or phrases. The authors reduced the number of attributes by omitting the duplicates, omitting the terms that were not commonly used, and merging the terms with similar meanings. This resulted in 22 attributes of 3 categories that are temporal, spatial, and global. The second task was attribute rating. With 22 attributes made in the first task, participants were asked to rate each of the 7 stimuli on 7-point bipolar attribute scales. Similar GUI was used to switch between 7 stimuli. Participants rated on a paper with pencil. The third task was pairwise comparison. Participants were asked to rate on global dissimilarity between 2 stimuli with 7-point scale. They were asked to consider any and all differences they can hear. Collected data from task 2 and 3 are analyzed. First, individual differences scaling, IND-scale, was used on dissimilarity data. IND-scale is a model of multidimensional scaling that takes participants' rating weight on each dimension into account. We used Smakoff package on our statistical software. The result is shown in the plot. Pairwise perceptual differences between stimuli are mapped into distance between pairs. So, closer the symbols are, closer their impressions are. Dimension 1 seems to be related to playback mode, that is, with or without loudspeaker simulating filter. To our surprise, dummy head is among stereo microphones. We thought binaural recording will be mapped far from the other stereo recordings. Microphone settings are aligned along dimension 2. Correlation coefficient between attribute ratings and IND-scale coordinates were calculated, and the attributes were drawn as arrows on top of the IND-scale stimulus space. Longer arrow has higher correlation coefficient with the corresponding dimension. Microphones in the right hemisphere are rated sharp and its localization accurate. 2 main stimuli, colored in blue on top left, are rated high in envelopment, environment width, and reverberation. Among 22 attributes, sharp, reverberant, and envelopment showed moderate correlation of p greater than 0.4. Sharp may be related to application of loudspeaker filter, which largely changes the sound image. Reverberant and envelopment may be related to microphone setting differences. The 22 attributes included 3 global attributes: reality, quality, and preference. 3 of them are weak, but in direction of the top right, where main and wide stereo microphones with OSD playback are. Reality was translated from Japanese term rinjoukan, which literally means sense of being there. And to our surprise, dummy head recording was not in the direction of reality. These attributes are not strongly correlated with in-scale dimensions, but may be predicted from other lower-level attributes. Multiple regression analysis with stepwise model update and manual adjustments were done, and the models shown are obtained. What we are interested the most is reality, and reality is related to solid and envelopment. Solid was translated from Japanese shin ga aru, which literally means the sound has a core that felt solid inside. It suggests that it includes the meaning of how distinct each instruments are. The two terms solid and envelopment jointly suggest that both sounds of instrument and environment are important for sense of reality. This agrees with what Ando mentioned, which is that there are object reality and field reality. We compared three types of reproduction modes, namely binaural, stereo, and crosstalk cancelled stereo on OSD loudspeaker. We found that stereo recording playback on OSD can be comparable to that of dummy head recording. Among the attributes, sharp, reverberant, and envelopment had moderate correlation with in-scale dimensions. This concludes my talk. Thank you for your attention, and I'll be happy to answer any question.